All right, welcome back to Mr. P Helps with Calculus. This is Unit 1, Day 1, and we're going to be talking about defining a limit and finding values of f of x and being able to graph that limit. So in this first warm-up, we have a quadratic function here, and we're given a table of values for x, and we can plug those in. If I put -4 in for x, I get -1. -1 squared is 1. 1 times 2 is 2. 2 minus 4 is -2. And I'll do the same for this, 0, 0, and this makes -4. -2 is 1, 1. 1 times 2 is 2. 2 minus 4 is -2. And that makes sense because that's those are going to be the same, and then these will be the same. So -1, it's quadratic, so it's going to be a parabola. -1, that makes 2. 4 times 2 is 8. That makes 4. 3, 9, 18 makes 14. Okay, but that's not going to fit on the graph. So -4, 1, 2, 3, 4, -2, -3, -4, 2, 3, 4. That looks like that's going to be the vertex, -2, -2, and then 1, 4. -1, 1, 2, 3, 4. All right, so the parabola is going to look something like this, and you know it's going to be the exact same on the other side because that's the nature of parabolas. All right, so introduction to limits. So what is a limit? A limit is our best prediction of what a point is happening at an observed spot. So in other words, we're going to give you a domain, and you're asking, what's happening at that domain of the function. And we can figure out our predictions by finding what's happening on the left side and the right side, and it's basically the behavior of the graph at that one point is what we're trying to do. Now, for instance, if we were watching a video clip and we were watching, a soccer game, and right in between the first, this second, and then it buffered, so you didn't see what happened here. So as the ball got kicked, the ball's in front of the goalie, and then now all of a sudden the ball's behind the goalie. What we can infer is the fact that the ball was somewhere in between this point and this point. And that's sort of what we do for limits. We see what's happening before and after the play, and we figure out where we predict is going to be in between. And that's sort of what our limit is. Or sometimes we're going to be talking about later on the limits as we go towards infinity. So it's a prediction because, infinity isn't technically a real number. So we're predicting what's happening at the end of a function, either end. So both positive and negative. So we have, so the limit of f of x as x is approaching, so this arrow means approaching c, some sort of number, or value typically, will be our answer. So our L will be our limit. So we are strongly predicting that that'll be the point that it's approaching from both sides. So sometimes it will not have a limit, and that's possible. If 2 points do not approach the exact same spot, then we say that that limit does not exist. It needs to be two-sided. It needs to be coming from both sides. So it's not always going to be equal, so limits does not always exist, as I mentioned just a second ago. Now, table of values, I'm going to strongly suggest that you use a calculator for these. What I'm going to do is I'm going to simply put this function in for y equals, so you can see what I'm doing. So I'm going to put in x squared plus 1 for y sub 1. And then the easy way to do this is to press second calculate, which will give you this table. And then click number 1, which says table of value, which means I can input any value that I want. It's going to do this. It's going to say x, and it wants me to pick what to put in for x. I'm going to put in this number, 0.9, press enter, and it's going to give me an answer of 1.81. So I know that that is the height at that domain. And so that's tenths. So I want to find the limit at 1. So I'm going to keep getting closer and closer and closer to that value. So once again, I'm going to calculate a value, but this time I'm going to put in 0.99, which is a little bit closer to 1, and it's going to give me about 1.98. If I do that again, over and over again, what I'm going to find out is that I'm going to get closer and closer to the number 2, 1.998. So as I get closer to 1 as the domain, I'm getting closer to an answer of 2. Now, what will happen on the other side, 1.001, which is barely above 1, that gives me 2.002. The same thing's going to occur, only it's going to be backwards. So these numbers are also going to be approaching 2, meaning getting closer and closer. As I finish this out, 1.01 gives me 2.02, which is further away from 2. And one last one. If I put in 1.1, I get a value of 2.21. So once again, just so you can see what I'm doing, 2.21 is even further away from 2. So these numbers are getting further away. So as I get closer to that center, I'm closer and closer to that limit of 2. So that's basically what I'm doing there. So now let's use that, and here we go. So f of 2, that's just a simple function question. So when I look at this graph, f of 2 is negative 1, 2, 3, 4, 5. F of 2 is negative 5 because that's the point right there. That's a hole, and this is the actual value of that. But if we're talking limits, that none of this graph is approaching this point. So that's really the point here. No pun intended. So if I come in from the left-hand side, you'll notice that this graph is getting closer and closer to a height of negative 2. From both the left side and if I trace it this way from the right side. So whether it be from the left side or the right side, you are approaching a height of negative 2. Now that's not the answer at f of 2, but it is going to be the limit because that's the point that we were approaching. So taking it back to that soccer ball reference, this wouldn't really make any sense in real life, but however, if I'm going to assume that middle point was missing, that middle frame of that soccer ball, it wouldn't make any sense that here we have the ball at center field when clearly the ball was right in front of the goalie to behind the goalie, so we know it had to be in between the points. So using that as sort of a reference to what's going on here, so yes, the limit should be in between, but however, the answer is something else. F of negative 1, that's a pretty fairly easy one. So if I go left 1, the answer is 1. What is the limit as f as I get closer to that? Now, whether I come in from the left or whether I come in from the right, it really doesn't matter. It's still going to be at that point. They are both approaching the exact same place. Now, this one will be done just the same as the other one that I already did an example of. The only thing I want to go over, since I already showed you how to put it into the calculator, is this one's going to be a polynomial on the top. So make sure you, when you put this in the calculator, because calculator can be finicky about how it works, you have to put all the top in parentheses so that it knows to do that all first. Otherwise, it's going to do order of operations, and it's not going to give you the answers that are correct. So you have to put the top, the numerator and the denominator both in parentheses for it to work correctly. So make sure you put it in like this and then do the same steps that I provided a second ago. Then obviously this is going to have a vertical asymptote at positive 1, right? Because this is a rational function. It's going to have both a horizontal and a vertical asymptote. And basically it has the exact same steps. So this side should be approaching the exact same height as this side. Now if I put 1 in for x and solve, 1 squared is 1, 1 minus 1 is 0, 1 minus 1 on the bottom is also 0. Okay, so that's not going to work because obviously once again that is a vertical asymptote at 1. Not sure what I was expecting there. All right, so I think that pretty much covers us here. So you'll do the exact same thing for these questions. I would put these in the graphing calculator and then use it to calculate the table of values for you. Otherwise, you're going to be kind of pulling your hair out trying to put every single one of these domains into this equation and solving. So that takes a lot more work. So just looking at a couple of these practice, the tables I think we've covered. It says the limit of f of x as x approaches 0. Okay, obviously, clearly both sides of the function are approaching a height of 1, so that's the limit there. What's happening as x approaches 2 has a height of 0, so actually that looks like a hole, but yeah, the answer still is 0 because both sides are approaching the same point. As x is approaching 2, so the answer would be 1. Remember, it's what the function is approaching, not the value of 2. Yes, I realize the value of 2 would be higher than that. And what's happening as x approaches 1? Okay, now this one, that's what I was hoping would happen, does not exist. So there is no limit here, simply because at a domain of 1, they are not continuous, meaning that the function They don't meet up. So the left side is approaching a height of 2. The right side is approaching a height of 1. Therefore, the left and the right hands have different limits. So there is no limit to that one value. It's got to be the exact same. All right, so I'm going to pick up right from there on the next video. Thanks again for watching. Have a wonderful day.